I am part of the product management team here at Bentley and look into the concrete design, detailing, and drawing solutions from our stable. The tech talk today will focus on looking at how we are today able to deliver a completely integrated analysis, design, detailing, drawing, and documentation solution with a lot of solutions that we have, ensuring a completely integrated workflow for engineers. And this endeavor is to challenge the way we work currently, wherein we have a lot of silos that we tend to operate in, analysis separate, design is separate, and so on. And how can we work more efficiently, faster, and more accurately? Now, as engineers, you'll appreciate that we all go through this well-defined process or continuum. The moment we get an input from upstream, could be from a process or from an architect, as the case may be, we start with planning and modeling. So we translate that into how we as an engineer would want to support the structure. Once we get that confirmed with everybody, we move into an analysis stage where we build a structural analysis model. A lot of us, of course, use STAAD Pro, which is, of course, the favorite structural engineering solution for most structural engineers. And once we do our analysis, then we go to the downstream process. So that is converting that into design and detailing of individual elements, translating that into drawings, into estimations, into reporting, into fabrication, detailing, and so on. So the whole process, as you'll appreciate, though we would normally say is going downstream, but the truth of the matter for us as structural engineers is as we go from planning to reporting, the process becomes sort of more and more laborious. And that's because of two reasons. One is as we go downstream from analysis to design to drawing, more and more engineers or more and more people start getting involved in the process. The process becomes largely manual. As number of people involved in the process increases, the management issue and the bandwidth keeps on coming in. And this thus is a step up because we actually find that as we go from planning to reporting, the process becomes more and more labored and perhaps painful for a lot of us as engineers. And the reason for that, we believe, is because the process today, as we work with it, is largely fragmented. So there are a lot of solutions which tend to operate in silos. They're not interconnected. You need to transfer data from process A to process B. There is very little automation. So today, generating drawings, generating an estimation report, generating a bar bending schedule is largely manual, or you have solutions where you need to give in a lot of input to get the solution, give you an output. And consequent to this, the whole process, we believe, is very, very inefficient. And this is what we set out to set right. We said, hey, as engineers, we should be working at the cutting edge of technology and not working in a very IT or software inefficient processes you may have. So we looked at the current operating model. As engineers, as we saw, we have the process continuum, and we found that in the current operating model, true automation or complete automation, where I can fill in some data and get a complete output, primarily exists only for analysis. So we have STAAD and we have RAM and so on, wherein I can build a model, I can put in the loads, I can do an analysis and get the forces and so on and so forth. So I get 100% automation for that. But when I look at processes around it, when I look at a process of how do I arrive from a plan from an architect to a complete model, so how do I plan my structure? We don't have solutions which help us plan the structure. And once I do the analysis, we definitely have a dearth of solutions which integrate the design, detailing, drawing, estimation, reporting, that entire downstream detail engineering process in itself, which is leading to the concern that we have today. So what we said is, can we translate this operating model into a completely seamlessly integrated operating model? So we looked at developing solutions which integrate with what is good. So we believe that STAAD and RAM and do what they do very well, and most engineers who work with them have no reason to complain. So why reinvent the wheel? So we looked at the processes prior to analysis and post analysis and said, hey, can we bridge the gap, at the same time create solutions which are completely seamlessly integrated? So consequently, output from software A goes one click in its entirety into software B, and the whole process is completely integrated. So we have something called building planner mode and STAAD today, which is upstream of the structural analysis process. And the building planner looks to take the user from an input from an architect to actually planning the structure. And planning for us is locating the structural elements, sizing them prior to analysis. So most analysis solutions would require us to give the size of the members that we want as an input. So if I have a tall structure, and let's say I intend to reduce the column size vertically across the height, how do I arrive at that reduction? There is no solution today which points us to that. So this building planner actually looks to do that, looks at the pre-analysis concept stage or the planning stage and say, how do I facilitate this process for the engineer? And the output of the building planner is a STAD profile. So it actually creates an analysis input into STAD. Go into STAD, do your analysis, and post that we have the RCDC or the STAD Advanced Concrete Design, which takes over and takes you through the rest of the process. So this solution directly interacts with STAD, takes all the analysis output from there, and then takes you through an interactive design and detailing exercise so you can control the entire process. And once you have finalized your design and detailing exercise, it will take you through automated generation of all drawings, all fabrication detailing, all text documentation that we need to have, and all estimation reports. All of this is completely one-click automated. So in effect, delivering a completely seamlessly integrated operating model, which of course works very fast, reduces all the errors in the process, the checking time and the data transfer time and so on, makes the process very lean and efficient, and focuses on engineering rather than a lot of clerical activity, which as engineers we tend to do. Another important thing here, if you will notice, is the first two processes are connected two-way, and that's how the actual engineering process is, if you understand. I mean, it is never that it just flows from planning to analysis to design. There's always a conceptual design, there's a conceptual analysis, we go back, we make changes, we update the analysis model. So the process is not linear one way, the process is a collaborative two-way process. So when we build these solutions, we also appreciated this fact. This is how the structural engineer actually works. He needs to come downstream, take some output, go back and update the upstream, do a reanalysis and come back. So these processes actually facilitate this two-way process. And it's not just a linear one-way process, which is envisaged by a software engineer, but a two-way process which is envisaged by a structural engineer. So solutions created by structural engineers for structural engineers. And of course, it's good to talk about conceptually integrating and so on. Finally, I think for all of us as professionals, the bottom line is very important. So it boils down to what is the advantage in my process of using these solutions. And these advantages we classify into two types of advantages. One is what we call the tangible benefit, which is what you see on the screen here, which basically highlights that with a lot of automation, with a lot of intuitive automation and intelligent software, your process can be largely crushed, because your process involves, apart from active time, which is doing engineering, a lot of passive time is also there in the process. That is compiling information, giving it to the the next cog in the wheel, or the next person who's going to work on that. If somebody's done some output, it comes back to us, we need to check it. A lot of us has gone through the red and yellow marking philosophy. All of that takes a lot of time, and for us is a non-valuing passive process. Once we start automating and the efficiency of the outputs are 100%, the whole process becomes very, very, it crashes the whole process, and we believe that you can potentially save around 65 to 70% time and resources in this integrated process. The other thing that we don't see here is, as we look at focusing on design and detailing and planning and so on, there's a lot of intangible benefits that come in, because these are specific solutions which are looking to automate what today we did with Excel sheets or manually and so on, and consequently bring in a lot of diligence in that process, brings a lot of accuracy, and there's a lot of intangible saving in terms of optimized outputs, in terms of engineeringly optimized outputs, much better solution to customers and so on. So it's a double whammy of saving time and resources, also ensuring that your outputs, the engineering process itself, is highly value added. What we'll do from here on, so this is the conceptual background of what is it that we're talking about in this integrated solution. We'll just do a sneak peek into how these solutions actually run. So I'll just talk to you about how the process continuum is actually delivered. Now on the screen that you see, at the bottom you see the project timeline. So you see we are going from planning to analysis to downstream detail engineering. And of course the first area that we look at is planning and modeling. And this is where we looked at the fact that we have a tool or a software called Building Planner, which basically takes you from an actual architectural plan to a complete analysis model. What is screen on screen is the new screen of the Stat Pro Connect edition. For those who have not yet using that, I think you should. It's an amazing solution, a lot of value adds. But what you'll see here in principle is on the right, we've highlighted there's a mode known as the building or the building planner mode. So this kicks in basically if you're doing any sort of frame structure. It could be a tall structure, as you can see on the image. This is a 37-story structure, or it could be a small structure. As long as you have frames and you need to size the members, you need to locate them, orient them, and so on. This solution works very well. So what does building planner do? So I'll just spend 2 or 3 minutes on what building planner actually does. So it's very simple. We get an input as engineers from an upstream process. So we don't start the process of the whole project, right? So we get an input, let's say, from a structural engineer, from an architect or a piping engineer or a process engineer. And thus we basically have what you see on the left of the screen here, which is a center line. The process of modeling begins with this center line. So what the building planner does is it accepts this center line as an input. So you take the center line, click a button, just import it into the right, which is into the building planner. So it brings in that center line and starts the process of modeling. So what you see, the first thing that it does is identifies all these closed areas. It could be polygons or it could be irregular shapes, doesn't matter, that these are possibly slabs. It of course captures from the user the loading that he proposes to apply on the floor plate, and it starts suggesting thicknesses. So the numbers that you see are suggested thicknesses. And I will use the word suggestion because we have a strong philosophy here in Bentley which says that software can give an option to the user. Software cannot tell an engineer what to do. So you can suggest something and give the user complete freedom to work around. So let's say we suggested some thicknesses here, and the engineer wants to change it. Let's say there are some slabs which are 110 mm thick or 160 millimeter thick and so on. You want to change that to say same thickness or increase or a lesser thickness. Once you do that, the consequences of that are taken care of the software. So you take the engineering decision to alter the size of the member. Everything else which involves impact on the self-weight, so automatic calculation of self-weight, impact on computation of lateral loads and so on, is automatically accounted by the software. And then on this view, we've got a lot of automation tools. You click a button, it will suggest potential member sizes and locations. You click a button, it will tell you how to orient them and so on. You get beams, auto columns, a lot of those automated tools, and you can translate this center line into an actual layout which looks something like this. Now this is a tall structure, it's a 37-story structure, and this is the current iteration that the engineer is working with. So what you can see here on the screen is there are of course beams, slabs, columns, shear walls, there are cutouts. You'll find that this projection here is local, and consequently the columns are very small. The corner columns are smaller, inner are larger, and so on. So all of those engineering things that we take care of or that come in as a consequence of the actual geometry of the structure is taken care of. A couple of amazing value adds that we do. So if you will see here, all of these columns are aligned as they would be in the physical structure. Now generally when we work with analytical tools, we all would go and insert the column at the analytical CG. So for example, if I'm working in STAD, this corner column here would be put at the CG here, and consequently if you do an extrusion, generally the column will project out. Of course there are ways of bringing and aligning the column, but generally we avoid it because it takes a long of time to do that for every single column across levels and so on. So doing that here is very simple. I just select this column, I get this pop-up, and on this pop-up I just tell the software that I want to flush this column on these two faces. So what it does is it pushes the column inside, it flushes those two faces and automatically manages the offsets going into the STAD file. As an engineer, you don't worry about the mathematics, you basically take the decision that I want to flush this column. All the relative number crunching is automated by the software. Now please bear in mind that this is a column over 35 stories, so consequently as I go up, the size of the column will keep on reducing. Despite that, the engineer takes that decision just once, and the software will manage that wherever there's a change in column size, it will automatically reduce, change the offsets and so on. So all that is automated. We talked about column sizing. You can actually see on the right here, there's a load flow. So it actually works out the complete load flow across levels, and based on that, it suggests the column size. You can suggest to the software that, I want the same size over 3 floors, or next 4 floors, I want the same size. So it actually builds in all that practicality that we tend to do as real engineers in real projects. It also does a lot of parameterization. So if I'm applying lateral loads, if I'm doing something very interesting, let's say releases. In my typical project, I'm going to have a lot of, let's say, simply supported beams. So today what I need to do is I need to do a STAD MZ release and an MZ release. So let's say I've got 25 floors per beams per floor, and I got say 10 floors, I have 250 beams. I missed that setting in a few beams, and I will never figure out that I missed them. Very, very difficult. So what you do here is just take a simple call. You say, give me a simply supported action for secondary beams, which is the engineering intent. The software will identify the secondary beams. It will provide the MZ release and give you a stat file with all of that built in. So again, the essence here is to take the engineer away from numeric or geometric modeling to engineered modeling. That is, the engineer takes the decision what he wants to do, and the translation that into the mathematics and the equivalent syntax is all taken care by the building planner. And from all of this process, it creates an accurate analysis model. So the beauty here is we are actually creating the physical model. So if you see this pop up here, you can see, all the columns are rotated and aligned as they would be in the actual structure. All the beams are thus, framing from center to center. You can actually see the same in the pull out here. So in principle, we are creating the analytical representation of the actual physical model. More accurate your analysis model, more accurate we are upstream, more accurate the entire downstream process comes in, more efficient our entire analysis and design happens. So this in principle is what the building planner does and how it completely revolutionizes the way we typically tend to do planning and modeling for structures. It pushes that or creates an analysis file in STAD, one click, go into STAD, go into RAM, do your analysis as you would normally do, look at your hygiene factors such as deflections and so on, finalize them, and then move downstream to design and detailing. So as we move downstream to design and detailing, or the detail engineering as we call it, so the STAD Advanced Concrete Design or the RCDC kicks in. So in principle, it's an interactive design and documentation software for concrete elements. What does the software actually do? So interestingly, the first thing the STAD Advanced Concrete Design does is when it reads the STAD file, it reads it in entirety. So all the geometry, all the releases, all the specifications, of course the forces and load cases and combinations and so on. But importantly, it identifies the member design continuity. Because if I am doing design and detailing and I do not have the continuity, my design and detailing tends to be very theoretical. I need to take cognizance of the continuity. I need to take cognizance of how many beams are there in continuum. There are 3 or there are 4. What sort of flavor of detailing do I want to do? I need to take care of practicalities such as vibrator spacing and so on. So all of that is built into the software. So for example, in a model like this, let's say these 1, 2, 3, 4, 5, 6 beams are continuous. The software will automatically identify that they are a set of continuous beams and design and detail them together, especially the detailing. So to give you things like same reinforcement on both sides of continuous support here and so on. So all of that is taken care of. Or similarly, if I got these vertical objects, so if I have columns, instead, of course, you'll appreciate each of them is a different member number, but the software will automatically identify that this is one column comprising of different member numbers. Put that vertical, load flow or the geometry flow in place, appreciate changes in column size. So when it's detailing, it will reduce the number of bars. So it brings all of that sort of accuracy and practicality, the intangible that we talked about. Another amazing feature is the software will design, detail, look at optimization and give you an output. And I think the biggest concern or the, what we don't like about a lot of software is it gives you an output, but if you disagree with it, if you want to make changes, you need to go offline and use an Excel sheet or manual and so on. And that's where here it's completely different. You can completely change everything. You can change member sizes, material properties, rebar arrangement, whatever you want. The software will check for all sufficiencies during the runtime, and if required also gives you an option to go and update the member sizes back in the stat file. So it completely manages that change that you do. It also gives you a lot of visibility. So what you're seeing here on the screen today are a lot of visualization tools. So let's see these graphs here. What are they? Now this is a beam design and detailing graph. So these two graphs, the two first set of curves are for top reinforcement. This is a set of continuous beams. For each beam, the software automatically designs at 13 stations to get a beautiful L by 12 profile. What you see in red is the required area of steel profile. So the envelope of the required area of steel across multiple load combinations. And what you see in blue is the current provided area of reinforcement. So they're superimposed. So consequently, as an engineer, you can visualize what's happening, and then you can also make changes here. And as you keep making changes, the graphs will keep on updating to reflect your current change. So for example, if I don't want to curtail rebars here, I want to continue, I can just say continue this rebar here. This curve or this line will become straight, indicating to you that you're providing this reinforcement here. It might be more than required, but that's your decision, right? As long as it doesn't violate safety and code provisions, the software will not object. Or if you're working with columns and walls, instead of providing, saying that, look only at 36 number 20 dia reinforcement or 18 numbers or 12 dia reinforcement, what is very essential to us, you'll appreciate as engineers, is the location and arrangement of rebars. So within the software, you can actually visualize that. You can graphically make changes very, very simply. Just click and say change the reinforcement, add a bar and so on. And for every arrangement, the interaction, the 3D interaction surface is generated from first principles. So for every arrangement of rebars, material properties and so on, and on demand you can visualize them anywhere, anytime you want. You want to go into greater detail, you can actually feel free to do that. Now the RCDC or the Standard Advanced Concrete Designer basically looks at frame elements. So we also extend that experience into members which are modeled as finite elements. So if there are flat slabs, the classical flat slab with drop panel, column strip and so on. You have flat plates where you could have with and without drops, or just a plate sitting on columns. You have foundations of different types. It could be with piles, just a raft, a combined foundation of multiple columns and so on. And if you model that as finite elements, we can pick that up and take you through the design and detailing exercise. What you see on the left is a reinforcement required contour. So this is basically telling you that at a given location, say bottom X, in a given direction, this is the distribution of reinforcement that you need to provide. So you can actually see the heat map for that. And as you start providing the actual reinforcement, you will see they get more blocks. So the blue is, let's say, the mesh all over. Somewhere locally I'm providing extra. So this is the first iteration. A lot of tools to quickly change all of that. You click a button, let's say on this, and say regularize it from this jack shape. It will automatically become a rectangular shape area and so on. So all of that exists, and then you can visualize what is happening in 3D during the design and detailing process. So since they are much larger areas and they are three-dimensional floor plates, you can actually see that. So you can actually see the mesh, the local extra reinforcement, all the anchorages drawn to scale during the process. So the endeavor is to bring the site to the engineer's office, so you can visualize much better before it goes to site and then realizes, hey, something is falling, or I didn't take care of some reality and so on. So very, very interactive, and that's the trend that we go through all the solutions. And once you're through with that, we automate all the outputs. And this is the biggest strength, is basically to create drawings and fabrication detailing and so on. I'll just quickly run you through the kind of output that we generate. So we give you a layout drawing. So this is a footing layout drawing coming in from STAD. Now in STAD there are no grids, as you would know. There are no grid lines that it saves and gives us, but our drawings are incomplete without grids. So what we do is allow the engineer to capture this grid system, or in case you're working with something like a RAM where there's an existing grid system, we bring that in, and if you want to qualify that, you can do that within the software, but your drawing comes complete with everything. Or if I'm going to an engineering detail, you get a layout with reinforcement, you get a section with reinforcement, and all of these are to-scale drawn drawings with well-defined layers, textiles, dimension styles all built in. So it's completely organized, and there is a style manager. As an organization, you can configure it to maintain your organization standards, or if you're doing a project specific setting, you can also do that very quickly by just clicking a few buttons and getting an output the way you want to see it. So moving further, we give you a pile layout drawing, which is the first thing that goes on site as an engineer, locating piles, if it's column centers. We give you a pile cap layout drawing, so pile cap shades and size and dimensioning. We'll give you a detail engineering drawing, so we give you a plan with reinforcement, we give you a section with reinforcement indicating pile cutoff location and so on and so forth. Going further vertically, columns and walls, so we'll give you the cross section with reinforcement. Linking is provided, and you will get a copy of the links. So this basically tells the engineer or the guy on the site, how is this link set actually compiled? So I have a master link, I have a second set of link, I have a third set of links. So how is the link set actually compiled? So it actually gives you all that information within the drawing. More complicated columns and walls, with and without boundary elements, lift core walls. If you go to tall structures, you get a lot of walls with sort of merge into each other as you come to the lower levels. So you get a lot of these sort of complicated shapes. These are actual samples from actual working projects. Any size, any dimension. So just to give you a sense, this wall here is of 16-meter length. So it doesn't matter to the software. Columns of absolutely any shape from first principles. So for example, if I'm doing an I-shaped column here, we're not looking at the so equivalent rectangle and doing that. We're actually projecting the flange and the web independently onto the stress strain curve. So we are doing integration inside and actually designing from first principles. Columns of any shape, as you can see at the bottom right corner here, and interestingly, any of these edges can be curves. So you could have a curve anywhere, or let's say all of these edges could be curves, and you could have something like a cloud that is just pushing it. But practically speaking, very often, let's say we have some areas where architects will give you a curve. We can do that and design from first principles. The column elevations indicating the arrangement of reinforcement. Laps could be central at top of slab, staggered, or at same level. They could be laps, or it could be mechanical couplers. So as project specifications vary, all of this will change with that one click. Beam elevations, so indicating reinforcement layout across the beam. Section through the beam, the sections are automated again, so it detects where there are changes and automatically gives you sections. So you don't need to worry about that I forgot something, or one section I did not do a blow up, and so on. All of that is automated. These are all one-click generated drawings, mind you. The framing plans with your grid lines, your dotted lines, your cutouts, and so on. For slab, the reinforcement in plan. So on the left is the support reinforcement, on the right is reinforcement at the bottom. Again, completely automated from your design. Section through the slabs, section through the staircase. For flat slab structures, we give you the layout drawing, so the layout with the middle strip, drop panels, and so on. We also give you the reinforcement in plan with the mesh and the local extra and so on. If I'm working with rafts and so on, or even for flat slabs, you can get a layout, you can get a reinforcement drawing. You can also cut sections wherever you want. And the sections could be through the entire structure, as you can see here, or they could be localized. You can define your stress section and the reinforcement section, or just a concrete section is generated. And you can see the kind of complexity here. Some of them are pedestals, the lift core is going down. It doesn't matter, all of this can be taken care by the software. A lot of text scheduling, a lot of engineers like to use text schedules. So vertical schedules for slabs and beams, two-dimensional schedules for columns and so on. So columns are horizontal, all the engineering information was vertical, including the special confining links for ductile columns, the length of or the height of the special confining zone. So though it's a text output, all information is complete. And the bar bending schedule, and this is completely again automated, so one click. So we will give you the rebar placement drawing with the bar tag. There's a bar tag tool. You can configure the string the way you want. It will give you the layout drawing, and it will give you bar bending with the shape, with the bending dimensions, the cutting length, and so on. For codes which support a bar shape ID, you can translate that into a bar shape ID, and you can connect it to a CNC machine directly and so on. All completely one click automated. What we also give you is a lot of reporting, because we believe engineering is incomplete without us understanding what is happening in the design. So we give you a detailed design calculation report, which is like a textbook. The whole process is laid out step by step by step. So anybody can understand what is happening. Anybody can check what is happening. Very, very essential in today's environment. So all of that is the detailed design calculation report. A summary is like a track 3 instead, a much more concise output. A failure diagnostics is very important. So let's say you design some elements or do a design exercise and some members fail. The first thing that we would look at is the failed element. So it will tell you which member, which location, which load combination, why has it failed. So as an engineer, if you know the reason for failure, you can decide what the corrective action could be. So it's giving you some decision making tools. We of course giving you detailed estimation for concrete, rebar, and shuttering. So we'll get at a member level, at a diameter level, and so on. So all of that we'll see very soon what they are. And we track all the changes that you're making. So if you're changing member properties and sizes, you get a statement saying, hey, these are the changes that you made from the original STAT file, and there is a flexibility where you can go and update the stat file with revised member sizes and do a reanalysis. So as I said, the two-way process of coming into design, do preliminary design, change member sizes, and we can go back into analysis. A typical design calculation report looks something like this. So this is for, let's say, a slab. So it's in great detail. It starts with the coefficient, the unfactored shear force, the factored shear force, the stress, and so on. As I said, like a textbook, the whole thing laid out step by step by step. A BOQ or an estimation report summary looks something like this. You get concrete grade wise, rebar shuttering wise, you get, sorry, rebar diameter wise, shuttering, PCC, excavation, and so on. And as an engineer, you can define the rate and the currency depending on wherever the project is. It will translate the quantity into a cost estimate, and then you can drill down this into greater detail. So you can get for each column or each beam what is the concrete consumption or the rebar consumption and so on. Actually go down to that level in itself. So in a nutshell, this is what we do. We run through the entire design continuum, starting with the building planner, which highlights or looks at the planning exercise, translate that into an analytical model, do that in STAD or RAM, and use RCDC design tools to completely automate your design, detailing, drawing, documentation, and estimation exercise. The whole thing completely integrated and automated. Just to share the kind of projects that a lot of engineers are using our solutions on. So tall structures, a typical tall story, multi-story design that happens. A lot of the hotel projects, so again, different treatment as you know with the service load and so on. All of that are handled in the software. IT parks, so of course, a large part of what we tend to do here. IT parks, mixed use structures, malls and commercial establishments and so on. Industrial infrastructure projects, so metro, a lot of the metro stations, we part a lot of metro stations across the globe. Stadiums, very interesting. So these are modeled as curved beams. So again, wherein we automatically detect the continuum. So stadiums and so on. One of the most complicated structures that we've been part of is this structure. For people who know it, it is the residence of the richest man in India. This is a structure in Mumbai. And you can see the actual structure. You can see the STAD model. So proud to say it was actually done in STAD. And Vishwas, who's my colleague here, was the project engineer on this. So this, of course, is his model, and this is designed and detailed in RCDC. And as you can see, it's just the top, which is the helipad, which is actually in steel, and the rest of it was actually concrete. So yeah, we can push that to a lot of levels, and with the advanced concrete designer, completely take care of the design, detailing, and so on. Another very large and complex project that we were part of, or the technology has been used in, is the Petronas Rapid project in Malaysia. So this is done by a company called Toyo Engineering, and they used the software to deliver a lot of these industrial structures. And they had a couple of interesting problems where they had to use the Euro code with the Malaysian annexure, which is very new to everybody, including the peer reviewer and the consultant. And the other problem was they were using this project was so large that they were using it across 6 or 7 different locations, and they need to ensure that all the outputs are standardized in the same format. The peer reviewer accepts it, the client accepts it, and so on. So this is very, very successful. And then we went on. It became a major entry in the year-end infrastructure last year. Won a lot of accolades and became a huge case study. So it actually is a case study now here in Bentley in terms of how we can use these technologies to make the whole process faster. And we've actually created a beautiful video which outlines this entire workflow and how Toyo was able to maximize on its workflow by using these technologies. So this is I'll end my talk here. We'll end with a quick look at that video, and then perhaps post that, move on to any question and answers that you would have. So Sally, if you could take it from here.
Toyo Engineering, a global leader in engineering and construction for industrial facilities, was contracted to deliver a large-scale ethylene complex, the largest liquid-based greenfield downstream in Malaysia. Toyo was responsible for delivering the facility on a turnkey basis on a tight timeline. With a project of this magnitude, several challenges were presented. For starters, the plant required complex analysis for various structural elements, ranging from pipe racks and buildings to equipment and infrastructure facilities, all on a tight timeline with a multidisciplined team. Also, like many industrial structures, the design contained columns with transverse and longitudinal beams at different levels. And there was a unique challenge in that they needed to design in accordance to the new European standards, which were unprecedented in Malaysia. In order to meet quality standards and strict project timelines, Toyo realized they would be required to integrate and streamline the engineering and analysis processes. They relied on Bentley's STAD Advanced Concrete Design application to meet the project demands. STAD helped the distributed team share up-to-date synchronized data and easily update their designs and drawings in real time. They were able to perform iterative multidiscipline design checks and streamline workflows to save time, reduce redundancies, and eliminate errors. Toyo was able to accelerate the entire workflow by 30% with Bentley's structural design applications and reduce construction time by 10%. To ensure design accuracy of the columns, the team was able to quickly generate reports to easily understand the concrete behavior. Using STAD, they were able to quickly define the load combinations, iteratively check the design, and automatically adjust the sizing of the foundation. Toyo applied advanced engineering design codes using STAD to comply with the new European standard codes consistent with local design regulations for Malaysia, which set new country standards for concrete design. The ability for Toyo to automate engineering calculations, drawing production, and report generation optimized their design and efficiency. Using STAD, they were able to complete the conceptual design and detailed engineering within 18 months and obtain early approval by the client. Bentley's integrated structural design applications accelerated the entire workflow by 30% while ensuring standardization of processes and uniformity of deliverables across multiple locations and teams. STAD Advanced Concrete Design. Form your future. www.bentley.com/STAD.
Thank you. We welcome questions. We already see a few questions pouring in, so please type in to the Q&A box, and we'll love to, take that on.
Yes, Sajid, there is one question by one of the participants asking about whether RCDC is integral part of STAD.
So RCDC currently, commercially, if you're asking, is not an integral part of STAD from a commercial standpoint. The product is completely integrated, so it's something like STAD Foundation Advanced, where you can go in from STAD to Advanced SFA directly. Similarly, you can go from STAD to RCDC directly, but commercially, you need to procure a separate license for that.
Right. Then there is one question regarding beams. So what is grouping and what is mirror in straight? So I think I can take that. So if you have similar locations, of beams in plan, then in design you can group them so that your design is similar for the entire beam group. In some cases there could be a direct alignment of the beams, and in some cases they could be actually mirrors. So you have, let's say, two wings on each side of the staircase, then you could potentially have a mirror group. So that's the use of grouping in straight and mirror. I hope I am answering the question correctly in that. Other is whether RCDC and RCDC FE both consider slabs which are sunk or with drop. So yes, we do consider. So whether it is part of the model or not, you can come in RCDC software, and inside RCDC software there are provisions to enable either raising or sinking of the slabs, and then the effect of that into design and detailing is considered. Another question is there any plan, Sajid, I think you can take this. Is there any plan in future to directly integrate SACD in StatPro GUI, such as RAM connection?
So yes, we might be. So what will happen perhaps in the next release coming in, we will give a call out to Stat or a launch to a SACD from StatPro as the SFA is, and whether it goes completely integrated, I think that's not a decision that we've arrived at now. That might be in the future. But as of now, what will definitely happen is you'll get a launcher or an area where you can go into advanced design and directly call RCDC from within the Stat environment.
Right. Some of the questions is like in generating BOQ in RCDC, what are the currencies that you get? So, Sajid, I think we have dollar, rupees, pounds, euro, right, and yen, if I'm not wrong. And I think Singapore dollar also.
Yes, I think we
if
can
there
add
is,
a few. I think.
yeah,
True. Yeah.
okay. Then there are some queries which perhaps demand a demo slightly perhaps. So maybe we could set up a demo for these people who are more interested in specific feature of the software. Again, they are mostly related to how to sync the slabs and all of that. So I think we could organize for a demo depending on the level of interest that they have. Another question is whether RCDC FE and RCDC are the two separate softwares.
Yes, very much so. Very much so. So we have two separate softwares and two separate licenses. Yeah.
Right, and I think the primary reason for that is that RCDC FE handles something that has been analyzed using finite element method, whereas RCDC handles the normal model. So that's why the method of analysis as well as the approach toward design is different. So that's why they are completely separate products with completely different UI for each treatment appropriately. Whether it will support water returning structures as per IS code.
In the future, RCDC. Yes. No. RCDC FE will go into that area in the future. Not currently. Perhaps this time next year it should be doing that.
Okay. Another question that we have is there any benchmarking done? So I guess you are talking about these standard solutions with the standard output. So we have validation outputs created for each of the elements, which can be verified by user by referencing any of the common available textbooks or methods of calculation. There is one question regarding what is new in the latest version. So I guess this question is more about RCDC in specific. So I think Sajid, can you take it up?
So I think we should take it at a different forum. We can send across what is new. Let's not talk about that here.
Absolutely, yeah.
Because they're releasing at different times.
Absolutely. Is there any plan in future to update SACD VATI to SACD Connect Edition?
Yeah, might. That's more technical. So of course it's coming in from a channel partner. All right. Bentley solutions will move to Connect Edition. So that is, all of them will, because it gives the user much more leverage on the cloud and information that is available. So that will definitely happen going further. Timelines are not available now when we will be doing that. But yes, going further, SACD VATI will become SACD Connect.
Okay. SACD or RCDC is a standalone software, so it is not part of the normal STAT software. So for anybody who is interested in the software, it has to be bought as a separate license. So I think the pure technical questions like shear modeling, I think we can take them separately in a different forum perhaps.
So just to say that it's the way the user is modeled, we can read and design. So if you're using, let's say, a RAM, which we would recommend more for shear wall based wall structures. If you're using RAM structural system, the wall is modeled as a finite element mesh, and we get that output from there, and we can do that. With the connected StatPro Connect Edition with the walls coming in, yes, hopefully the next release will look at the wall that is modeled as a finite element from the StatPro physical modeler, and we'll take it up in design. Yes.
Okay. Is it possible to combine different materials, that is steel and concrete together? So currently it doesn't support, but yes, of course, there are plans for future development for going into composite, if you are asking that.
There is embedded.
Another is embedded, yes. So either it could be composite steel column or composite steel beam, both ways. So is there any plan to include BS and Euro codes in RCDC FE? So Euro is under development. BS. Is there any plan to include BS or a Euro code in RCDC FE?
Yeah, please go ahead.
Yeah. So Euro code development is under progress. BS, if there is a decent demand in market, perhaps we can look to do it. If I'm not, because as of now, BS is actually been substituted by EN everywhere.
Apart from Malaysia.
So
but we should also
want to add
the code in
this?
RCDC. Yeah. The codes in RCDC.
Yeah. So RCDC, we have already ACI 318-2011, 2014 will be released very soon. Of course, we have IS, so both the old ductile detailing code as well as the new code. We have the old BS code 8110, and we have Euro code, the main Euro code with the UK, Malaysia, and Singapore annexures as part of RCDC. Can we change bar diameter and spacing as per our requirements after design and analysis? So of course, so RCDC has a lot of detailing options where user can do a micro or a macro detailing, and can actually do absolutely any localization of any detail in cross sections for any beams or columns. Will RCDC FE link with RAM concept? Sajid?
Might not discuss, not an agenda currently, but yeah, might.
Can we calculate earthquake and backfilling quantities as per ground profile? So for foundation modules, yeah. So in foundation modules, we actually calculate the earthquake quantities and backfilling quantities based on the design finalized by the program. And of course, the user has to give appropriate ground level so that we calculate the quantities based on that. Is the stage construction taken care of? So now this is more to pertinent to analysis. So if your analysis takes care of stage construction, then RCDC is only design software. It will read the appropriate design analysis data from the analysis engine, and then do the design detailing for that. SFR, so side face reinforcement in RCDC or beams for that matter, is calculated based on various principles. One of them is the deep beam principle. Other main criteria is of course torsion. So if you have any torsion in analysis that is coming out of analysis, then RCDC will handle the torsional detailing with SFR. Is it possible to design retaining walls in RCDC? So currently RCDC does not support specific functions for design of retaining walls. It handles, as we discussed, beams, slabs, columns, and foundations, isolated footings, as well as isolated pile caps. Whereas RCDC FE handles flat plates, flat slabs with drop panels, combined or raft footings, or raft on piles, or also isolated piles, if at all you have. What does a joint flexure failure in columns indicate, and what should we do? Okay, so this is specific question to I guess the new IS code that has been released. So there is a special check for capacity of joint at the junctions in IS 13920. So if you have this kind of failure report, probably you need to look at your column size to increase and add extra percentage reinforcement so that you satisfy the check. Also, we have some questions. So, how can one was asking, how can I maintain my drawing standards when the output is generated to RCDC? So, Sajid, do you want to take it?
Yeah, sure. So, RCDC is a concept known as a style manager, where the user can go in and specify the organization's preferred layer system, so layer description and color, dimension, style, fonts, and so on. So all of those which what sort of bubble you want for a grid mark, what sort of a section mark do you want, and so on. So it's a library you can select from that, and you can actually create a customized drawing style. This drawing style can be set as default. So the organization, whenever you generate an output, will use the organization's default style. Sometimes what also happens is, you need to create a specific output style for a given project. So the client demands that, please follow my style. So there is an option there again that you can create a drawing style which is for a given project and then load it into the software when generating outputs, and you'll get the outputs in line with those. So you can actually facilitate both of that.
Okay. Another question on similar lines is what is the format of outputs, drawings as well as other calculation reports as well as BOQ.
Sorry, I missed that.
So what is the format of outputs, drawings as well as the text outputs?
Okay, so drawings are in platform independent DXF format, but completely organized with layers, text styles and dimension styles and so on. The beauty thus is that you can generate the output and you can open that in MicroStation and any other CAD that are around, so ZWCAD and AutoCAD and so on. So it gives you that complete transparency and flexibility. Similarly, the design outputs by default, the text outputs are in platform independent format, so they are in HTML formats, but again they're completely organized and formatted. So you can directly open that in a word processing solution like a Word or OpenOffice. You can do that similarly with open it in Excel or in Calc if you're using that kind of platform independent medium. So both the outputs are platform independent, and you can work with any software upstream for that.
Okay.